Good morning, my dear students. So today in the sessions we are going to learn 8th problem on the springs. A rail wagon of mass 20 tons is moving with a velocity of 2 meter per second. Okay, velocity of 2 meter per second. It is brought to a rest by two buffer with a spring of 300 mm diameter. The maximum deflection of a spring is 25 mm. The allowable shear stress in the spring material is given as here 600 Newton per millimeter square. So first of all, we need to design the spring for the buffers. We need to design in this problem. Let's see the mass of rail wagon. How much is given here? It is given as 20 ton. 1 ton equal to 1000 kg. How much here? 1 ton equal to 1000 kg. 20 ton equal to 20,000 kg, we can say. The mass of rail wagon M equal to 20 ton. 1 ton equal to 1000 kg is moving with a velocity of 2 meter per second. The velocity of this rail wagon, how much is there? 2 meter per second. It is brought to rest by two buffer with a spring of 300 mm diameter. Okay, this diameter of this spring is given as D equal to 300 mm. The maximum deflection of the spring is given as, it is represented by, maximum deflection is represented by Y equal to 250 mm. The allowable shear stress in the spring material is given as 600 Newton per millimeter square. The maximum allowable shear stress, it is represented by tau equal to 600 Newton per millimeter square. So design the spring for the buffer. Okay, design the spring for the buffer. So in this case, the number of spring with buffer we are assuming as n equal to 2. Okay, so we know very well the kinetic energy of the rail wagon is absorbed the some amount of energy in the form of strain energy of the spring, we know very well. Okay dear, so the kinetic energy of the rail wagon, it is represented by 1 by 2 mass into V square, 1 by 2 mv square. So here 1 by 2 force into Y into number of the spring. Here 1 by 2 as it is. The mass of the rail wagon, how much is given here? 20, here already given. The mass of the rail wagon is given as 20 into 10 power of 3. 20 into 10 power of 3. Velocity of the rail wagon, how much is given here? 2 is given, equal to 1 by 2 force. Force we don't know, we need to find out. Y is the deflection of this spring. Y equal to 250 mm. If you want to convert in meter, means 250 into 10 power of minus 3 into meter. If you multiply, then you will get 0.25 meter. Is it right? Deflection is 0.25 into how many number of these springs will be there? The number of the spring with the buffer we are assuming as 2. If you cross multiply, this 1 by 2 and this 1 by 2 will be cancelled. The remaining unit 2 here, the remaining terms should be 20 into 10 power of 3 into 2 power of 2. If you multiply this whole the value, then you will get 40,000 equal to F 0. Here 0.25 remaining. After that, if you divide the whole the value, here, then you will get F is equal to 60,000. Okay, 160000 Newton you will get. Okay, 1,16,000 you will get. After that, you need to find out torque transmitted. The torque transmitted already we are we used this formula in the maybe fifth or sixth problem. Is it right? What is the formula? Torque T is equal to force, maximum force, into d by 2. This T value, what is the formula? Pi by 16 into shear stress into d cube. Okay dear. So first of all, we need to solve one by one. T equal to force, how much is there? 16, 4 times 0, 16 into 10 power 4, we can say, into diameter, how much is there? 300 by 2. If you divide the whole the value, you will get 24 into 10 power 6 you will get. So what is the unit of force? The unit of force is Newton. The unit of diameter is millimeter. So for that reason it is considered as equation number 1. After that, torque formula T equal to pi by 16 into tau into d cube. T equal to pi by 16 into tau into d cube. Pi by 16 as it is. Shear stress value, how much is there? 600 Newton is already given. The maximum allowable shear stress value is given as 600 Newton is given into d cube. If you divide this whole the value with the help of calci, then you will get the answer is 117.809 into d cube. So it is considered as equation number 2. If you are equating this equation number 1 or equation number 2, then you can easily get the value of d. Okay, how to equate? Let us see over here. First is t value is 24 into 10 power 6. 24 into 10 power 6 equal to, equation 2 is 117.809 into d cube. If you divide this value, 24 into 10 power 6 divided by 117.809 equal to d cube. If you remove the cube, it is make as the power is 1 by 3. D equal to how much? 58.84 mm. So this 58.84 mm should be approximately equal to 59 mm. So after the getting of the d, you need to find out the spring index value. What is the formula? Spring index C is equal to capital D by small d. Okay, so capital D is how much is there? 300. But diameter of the coil is how much is there? 59. If you divide this whole the value, then you will get the spring index is 5.08. It should be approximately equal to 6. Okay, after that, after getting the spring index value, you need to find out the value of Wahl's factor. If you want to find out the value of Wahl's factor, you have to use the formula is K is equal to 4C minus of 1 divided by 4C minus of 4 plus 0.615 by C. Okay, refer the equation number 11.2a, page number 169. So 4 as it is, C is how much is there? 6 minus of 1 divided by 4 into spring index is 6 minus of 4 plus 0.615. Spring index is how much is there? 6. If you divide the whole the value with the help of calci, then you will get the answer is 1.2525. After the getting the value of K and C and D, after that we have to use the maximum shear stress factor formula. So what is the maximum shear stress factor formula here? Tau is equal to 8 into force into spring index into Wahl's factor into divided by pi into diameter of the coil. Is it right? So in this case, what we need to find out? We need to find out the diameter of the coil. We need to find out, or we can say as diameter by the curvature. We need to find out the maximum allowable shear stress. How much is given here? 600 is given into 8. The force how much is given here? 16 into 10 power 4 into C how much is given here? 6 into K how much is given? The Wahl's factor value 1.2525 divided by pi into d square. So after that we need to cross multiply this term. D square is here. The remaining should be 8 into 16 into 10 power 4 into 6 into 1.25 divided by pi into 600. If you divide this whole the value, then you will get 71.43 mm. Okay, after the getting the d equal to 71.43 mm, it should be approximately equal to 72 mm. Okay, the diameter of the coil. After that, we need to find out how many number of the turns of the coil we need to find out. For that reasons, we need to assume in this equation G is equal to 0.07845 into 10 power 6 megapascal. 1 megapascal is equal to 1 Newton per mm square. We know very well from the high carbon wire. So refer the table number 11.5, page number 190. I equal to Y is the deflection into modulus of rigidity, diameter of the coil divided by 8 into force, C nothing but spring index. Refer page number 170, equation number is 11.6. So I equal to Y deflection is 250 into 0.07845 into the power of 6 into 72 by 8 into 16 into 10 power 4 into 6 cube. If you divide the whole the value, then you will get the number of tons. The number of tons is 5.107. This 5.107 should be approximately equal to the number of the tons should be 6. Okay, after the getting the number of the tons, we need to find out the value of pitch. P we need to find out. If you want to find out the pitch of the free length, then we have to use this formula. LO of the free length is equal to number of the turns plus 2 into diameter of the coil plus Y plus clearance. Okay, so we know, so you have to refer the page number 174. Equation is 11.18a. So in this equation, what we need to find out, we need to find out the value of A. So A equal to X into D into I. So in this equation, we need to find out X, D and I. This A clearance we can easily get from the page number 174, equation 11.18c. Okay, refer the figure 11.6, page number 174. For C clearance, C is given as, sorry, spring index is given as 6 and diameter it should be greater or equal to 0.8 mm. X is 0.15. A is as it is, X value is 0.15. you have to put it. D value is how much? 0.8 mm. Okay, then into 72. Okay, I is the number of turns. How much is that here? Number of turns is given as here 6. Okay, and in this case we have to assume this value is here. Instead of this 8, you have to take the value, this one, which one? 72 mm. Okay dear, 72. Okay, if you multiply these terms, A is equal to 0.15 into 72 into 6, then you will get 64.8 mm. The free length value you need to substitute because you are getting the clearance value A. The free length LO is equal to I is the number of turns, how much? 6 plus 2 into D, how much? 72 plus this Y is how much? 250 plus A is clearance, how much? 64.8. So if you are add this whole the value, then you will get the free length 890.8 mm. So after that, we need to assume the table 11.4, page number 189. Assume square and ground and type D you have to assume because the same concept already we have solved in the previous problem. Is it right? The actual number of the coil I dash equal to number of the turns plus 2. The number of the turns is how much? 6 plus 6 is there. 6 plus 2 equal to how much? 8. The actual number of the coil, how much it will be that here? Actual number of coil, or we can say as active number of the turns. We can say how much will be there? 8. And the solid length equal to I plus 2 into D. I is how much? The number of the turns is 6 plus 2 into D value is 72. If you multiply the whole the value, then you will get the solid length should be 576. If you want to find out the free length, LO, I plus 2 into D plus Y plus A equal to, we can say as I into pitch into 2 into D. So this whole the value I plus 2, okay, plus Y plus A, then you will get from this equation here, already we have solved here, I plus 2 into D into Y plus A, how much you got here? Free length is 890.8. the same value you have to substitute here, this whole the value 890.8 equal to I, the actual number of the coils. This how much will be there? Number of the turns should be 6. We need to find out what the value here, pitch we need to find out, P as it is, plus 2 into D, how much? 72. If it is moved toward like from toward left side, 890.8 minus 2 into 72 equal to 6 P. If we divide the whole the value, sorry, 890.8 minus 2 into 72 divided by 6, then you will get the pitch is 124.46 mm. After the getting the pitch value, you need to find out the inner diameter of the spring. We need to find out. If you want to find out the inner diameter of the spring, the inner diameter of the spring should be equal to the mean diameter minus of diameter of the coil. You need to find out. So inner diameter as it is, the mean diameter is 300, or diameter of the coil is 72. If you subtract this whole the value, then you will get the, sorry, if you subtract this value, then you will get 228 mm. Okay, now dear, after the getting on the inner diameter of the spring, after that we need to find out the outer diameter of the spring. We need to find out in this problem. So how to find here? Outer diameter equal to mean diameter plus D. Okay, so if you subtract, minus means it should be inner, if you plus, if you add instead of minus, plus if you add, it should be outer diameter of the spring. Is it right? The mean diameter how much will be there? 300 plus the D how much? 72. If you add this whole the value, then how much will you get here? 372 mm. So we understood that the inner diameter of the springs is 228 mm, the outer diameter of the springs is should be 372 mm, and the pitch of this pitch, the between the two spring is how much? 124.46 mm. Because we got all the concept, because I hope so no one is having the doubt regarding up to here. If you have the doubt regarding up to here, please, so if you have the doubt regarding anything, please write down in the comment box, and please don't forget to subscribe my channel. Thank you dear.